Have you ever made a joke about a weatherman? If you have, then your joke was probably directed to how the weatherman was wrong in his predictions. Well, hopefully, through this module, you'll get a small taste of what it's like to try to predict weather. Now, the weathermen on TV, they have all sorts of computers to help them make predictions. Since we won't have those computers, then we are probably not going to be very accurate in our predictions either. But that's okay, as we are only wanting to get a brief introduction into weather predicting here in Module 8. First, let's get an overview of the different types of precipitation. We're going to start off with two theories as to how rain is produced in a cloud. The first theory is called the Bergeron process. The Bergeron process takes place in what we call cold clouds. Now remember, that term cold is a relative term. What do we mean by when we say cold? Can we quantify this number? Well, for the most part, let's just think of cold as being below 32 degrees Fahrenheit. Okay, below the freezing point of water. Because what's going to happen inside that cloud is there are going to be ice crystals. As the ice crystals begin to fall through the cloud, they're going to accumulate more and more moisture. And the ice crystal is going to get bigger and bigger. As the ice crystal gets bigger, it could come to a point where the wind forces in there are going to fragment the crystal into pieces. And so all those fragmented pieces will begin to fall through the cloud, and they will accumulate more and more moisture and get bigger and bigger. Eventually the ice crystal is going to become too large that it's going to fall out of the cloud. And so it'll fall out of the cloud in the form of a solid ice. As it is falling, if it comes across any warmer air, warmer meaning higher than 32, it could melt and it forms a raindrop and it falls as rain. If that ice crystal that fell out of the cloud does not come across any warm air, then it'll stay as a solid, either could be a snowflake or sleet or something like that, all the way down to the ground. The next theory that involves the formation of rain is called the collision coalescence process. This process takes place within warm clouds. Again, there's one of those relative terms, warm. What do we mean when we say warm? Well, we're talking about temperatures above 32 degrees Fahrenheit, where the water moisture is not going to freeze. So here what happens is we get a raindrop that begins to move around, or it could fall or it could be blown side to side depending on the wind currents. But as it is moving through the cloud, it accumulates more and more moisture. Eventually it's going to get large enough where it too is going to fragment. When it fragments, now we've got smaller droplets moving through the cloud, which again begin the process of accumulating more and more moisture and getting bigger and bigger. Eventually the water droplet's going to be too large to stay within the cloud, and gravity is going to take over and pull that water droplet to the ground. This is the process of collision coalescence. Now that we've discussed those two processes, the two theories of how rain can be formed, let's talk about the forms of precipitation. The first form of precipitation I want to discuss is that of hail. Have you ever been in a hailstorm? It's kind of scary. I was in a hailstorm once inside my car, and it really sounded like I was in a war. I mean, it was so loud, those hailstones hitting my car. And once I realized what the sound was, then I started thinking, oh no, my car! Well, I had a bunch of little dents all over my car, so we had to take it to the body shop to get fixed here. Hailstones can be, as small as a pea, as a vegetable, or it could be as large as a golf ball, maybe even bigger. Here's a picture on the right of a record-setting hailstone, okay, that fell in South Dakota, July 23rd, 2010. It's the largest hailstone ever found. It had a diameter of 8 inches and the weight of about 1 pound 15, so almost 2 pounds. Whoa. Imagine what that thing would feel like getting hit by that thing. Whew. That could cause some serious damage to any object, let alone a person. Here's a website that I like to use in describing the different types of precipitation. Okay, here's its web address up here, www.atmos.iuc.edu. Okay, and it's the WW2010 University of Illinois website where they are discussing the different types of precipitation and weather patterns and so forth. Let's take a look at this website here. Rain develops when growing cloud droplets become too heavy to remain in the cloud and as a result fall toward the surface as rain. Ooh, wait a minute. That sentence sounds familiar. That one sentence right there is describing the collision coalescence process. Then it goes on and it says rain can also begin as ice crystals that collect each other to form large snowflakes. As the falling snow passes through the freezing level into warmer air, the flakes melt and collapse into raindrops. Ooh, wait a minute. That sounds familiar too. Those two sentences there are describing the Bergeron process. So here we've got 3 sentences that describe the 2 processes that are used, that we believe that, how raindrops are formed. Here's a picture here of a rainstorm. This says it was taken in Texas. You can see the rain that's falling from the clouds there. Hail is a large frozen raindrop produced by intense thunderstorms, where snow and rain can coexist in the central updraft. As the snowflakes fall, liquid water freezes onto them, forming ice pellets that will continue to grow as more and more droplets are accumulated. Upon reaching the bottom of the cloud, some of the ice pellets are carried up by the updraft back up to the top of the storm. As the ice pellets once again fall through the cloud, another layer of ice is added and the hailstone grows even larger. Typically, the stronger the updraft, the more times a hailstone repeats this cycle, and consequently, the larger it grows. Once the hailstone becomes too heavy to be supported by the updraft, it falls out of the cloud toward the surface. The hailstone reaches the cloud as ice, since it is not in the warm air below the thunderstorm long enough to melt before reaching the ground. Okay, you got the idea here? We have to have a very tall cloud. Do you remember what the tall clouds are named? Cumulonimbus. Because all of those ice crystals inside that cloud, they're going to fall through the cloud, collecting moisture, getting bigger and bigger and bigger. And then it's going to have a large updraft that needs to carry it back up to the top of the cloud. And then it begins to fall again in a downdraft, accumulating moisture as it gets to the bottom. And then if the updraft is strong enough, it'll carry it back up to the top. So we've got this continual cycle that's happening within the cumulonimbus cloud that's allowing these hailstones to get bigger and bigger. Eventually, this stone is going to be too large for the updraft to carry it back to the top of the cloud. And that's when it's going to fall to the ground as hail. All right. The next form of precipitation I want to talk about is called freezing rain. Freezing rain, it's not the same as hail, and it's not the same as sleet. We'll talk about sleet here in just a few moments. Freezing rain is what happens when rain hits our ground. Okay, it hits the ground and immediately freezes. Freezing rain can be a very treacherous condition for winter. Here are a couple of pictures that show the results of freezing rain. You see, the rain was falling as a liquid, but then as soon as it hit the cherry tree here, the tree was cold enough to freeze the liquid. And so the rain, when it hit, it froze and it coats everything. Freezing rain forms a layer of ice everywhere. And one of the things that we can lose during a freezing rainstorm is electricity, because all of the wires will be coated with ice. Makes them very heavy and makes them to where the telephone poles cannot hold them up. And so a lot of times power lines can go down. Trees can go down because of all of that ice. The tree is not designed to be able to hold that much ice. Let's go back to this website here and look at the page for freezing rain. Freezing rain is one of the most difficult events to forecast. The smallest variations in temperature, even only tenths of a degree, can mean the difference between rain, freezing rain, sleet, or snow. Freezing rain occurs less frequency than other winter weather events and falls in a very narrow band, usually not more than 50 kilometers wide. When attempting to forecast a freezing rain event, sounding data is very useful for examining vertical temperature profiles of the atmosphere. There are 4 types of sounding associated with the different types of precipitation. In the following diagrams, the blue line represents the temperature profile of the atmosphere, and the black line represents the 0 degree Celsius isotherm. That's the freezing point. When the blue line is to the right of the black line, it means the atmospheric temperature is warmer than 0 degrees, but when the blue line is left of the black line, it means the atmospheric temperature is colder than 0 degrees. So here's what these graphs are showing us here, okay? This black line right in the middle is the 0 degree. This is the freezing point. Anytime this blue line is to the left, that means the water will be a solid. Anytime the blue line is to the right, that means the water will be a liquid. And so way up high here in the altitudes, this is where the clouds are at the top. This is where the water is ice, okay? As it begins to fall through the atmosphere, when it gets to this altitude here, it reaches a layer of warm air, and it melts. And so over here, this is all elevations or altitudes that have temperature above 0 degrees. And it falls and it hits the ground. Now here's what happens with freezing rain. Okay, the rain starts out as a solid. It comes in contact with a warm layer of air, and it melts, turns into a liquid. This liquid, okay, falls further to the ground, but then eventually it comes in contact with a layer of air near the ground where the temperature is below 32. So why doesn't it freeze? Well, it doesn't freeze because there's not enough time for it. It's too close to the ground to freeze. And so when it hits the ground, it'll hit the ground as a liquid, but then as soon as it hits the ground, it turns into a solid. Now, sleet is very similar to freezing rain in that as it falls to the ground, it comes across a warm layer of air, but then it hits a cold layer of air, but higher in elevation, higher in altitude. And so the altitude then, it's far enough or high enough up that as that water droplet falls through, it freezes in the air, and it hits the ground as a small pellet. And here's the snowstorm. What happens with snow is that that ice crystal never melts. It stays as the ice crystal all the way down to the ground. So there's freezing rain for you. Okay, freezing rain is a condition where the ice crystal from the cloud comes across a warm layer of air as it is falling, and it melts into liquid water. But then that liquid water comes in contact with air that is less than 0 degrees Celsius, or the freezing point, but it doesn't have enough time to freeze before hitting the ground. Okay, the next type of precipitation we just talked about is sleet. A lot of people get sleet and hail confused, but they are 2 different processes. Sleet forms really, really small pellets of ice. Okay, as you can see here in the picture on the left, these pellets are much smaller than a penny here. And sleet is it covers the entire area. Okay, not like hailstones where there would be individual stones all over the place, but sleet covers the entire area there. And remember how we said sleet forms. Okay, sleet forms because the moisture that's falling from the cloud, okay, it's falling from the cloud, it's falling as ice, but it's going to come across a warmer layer of air, which turns it into a liquid, but then eventually it's going to come across a cold layer of air, and it will freeze in midair, and so it'll fall again as a crystal, and that's why they're so small. Okay. So again, here's another diagram of it. If we were look at it from the clouds, it falls as snow, and then the snow crystals melt, turns into water droplets, but then those water droplets refreeze into smaller ice crystals. The last form of precipitation we want to take a look at is that of snow. Okay. For those of you that live in areas which have snow, you're quite familiar with, but those of you that live towards the south of the United States, you may not be so familiar with snow. This is that fluffy white stuff that covers our ground. Normally, being from central Indiana, I'm quite familiar with it, but after the first snowstorm, I could do without it. Wish it could just go away. I've talked with people over the years that live in warm climates year-round, maybe like San Diego or Florida or Hawaii. And I always tell them that I would love to live where they do. And sometimes they'll say something like, well, we miss the seasons. We miss having snow and so forth. And then if they say something like, it won't be too long before you'll miss them too. I just look at them and I'd like to say, I'd like to try to figure that out for myself. It's something that I would like to experience. Being from Indiana and living here, I've always had to go through the 4 seasons, and quite frankly, I'm tired of the snow. Here's a couple of websites about the formation of snow here. Again, remember, snow, it falls from the cloud, but the entire time that the snow crystal is in the air, it stays in that frozen state. And so all of the air above is below 32 degrees Fahrenheit or 0 degrees Celsius. On a weather map, okay, here's what they're going to look like. Snow usually precedes a warm front, okay, as the entire air below, it's got to be cold. Remember, the warm air mass rises above the cold air mass, and if there's any moisture in there, that's when the clouds form, and then the snow begins to fall. And so you'll have snow out in front of a warm front. Farther out in front, the more cold air it'll fall through. And then these individual colors here, these are what we have. We'll have sleet will be the band right behind the snow, and then the blue would be the band of freezing rain, and then the green would be the band of rain. Okay, that precedes a warm front during the winter time. Now, it doesn't have to have all 4 of these bands. Sometimes it could have just the rain and the snow. Sometimes it could have just the snow. Sometimes you can have a combination of these. But that blue line, that's the one we don't want to be around. That's that freezing rain, and that's very treacherous conditions, and it causes power failures, trees to fall, and roads to be very, very slick. Take a look at this website here. Okay. This website is microscopic pictures, okay, close-up pictures of snowflakes. Have you ever heard the saying that no 2 snowflakes are the same? Okay. Well, as you look through here, you can see many different designs of snowflakes that have been captured and photographed. Now, these pictures were taken in 1902. Okay, Wilson Bentley. These are very famous pictures here. However, this is what led us to believe that all snowflakes are the same. But can we really say that? Can we really say that all snowflakes are the same? Well, right now it looks as though that's the case. They're never the same, but do we really truly know that for sure? No, we don't know that for sure. Okay, we would have to accumulate a lot of pictures like this to determine if any two snowflakes are the same. So the probability that there are two snowflakes the same, it is there. It is probable. Okay, but there's so many different variations that it's hard for us to believe that that they would ever be the same.